Bidirectional forwarding detection. According to RFC 5880, BFD is a simple hello protocol that, in many respects, is similar to the detection components of well-known routing protocols. So this is how it operates. This is basically from a document that I got from cisco.com. This is just my notes. Let me go back to the website itself, or document. So yeah, bidirectional forwarding detection. So let's talk about the benefits of using it. So here are advantages. Uh, there are several advantages to implement BFD over reduced timer mechanisms for routing protocols. Although reducing the EIGRP, ISIS, and OSPF timers, or BGP, can result in minimum detection timer of 1 to 2 seconds. Well, yeah, did not talk about BGP itself. BFD can provide failure detection in less than 1 second. Okay, because BFD is not tied to any particular routing protocol, it can be used as a generic and consistent failure detection mechanism for EIGRP, ISIS, and OSPF. Last one is because some parts of BFD can be distributed to the data plane, it can be less CPU intensive than the reduced EIGRP, ISIS, and OSPF timers, which exist wholly at the control plane. So this is how you configure it. So as you can see here, there's 2 steps actually. So you have to configure it on the interface itself, and you also have to, and number 2 is you configure it for the routing protocol that you are running on a router. So, and this here is just optional, and this here is optional. So as it says here, you start a BFD process by configuring it on the interface. When the BFD process is started, no entries are created in the adjacency database. In other words, no BGP control packets are sent or received. BFD Echo Mode, which is supported in BFD version 1 for Cisco iOS 12.4 9T, is enabled by default. Okay. BFD echo packets are sent and received in addition to BFD control packets. The adjacency creation takes place once you have configured BFD support for the applicable routing protocols. This section contains the following procedures. So yeah, and this is the summary steps on how you configure it on the interface, and of course the detailed steps. And this is how you configured it for the routing protocol that you're running on your router. So in this video, I'm just going to talk about how you run it on the interface or enable it on the interface, and how you enable it for under BGP routing process. Yeah, under BGP process. So configuring BFD support for BGP. This section describes the procedure for configuring BFD support for BGP so that BGP is registered protocol with BFD and will receive forwarding path detection failure messages from BFD. So yeah, prerequisites. BFD must be running on all participating routers. Okay, and I have a topology here that we are going to use. The baseline parameters for BFD sessions on the interface over which you want to run BFD sessions to BFD neighbors must be configured. So yeah, the configuration is actually simple. So this is the summary steps. So product BGP, ACE tag, yeah, you configure it after at the end of the neighborly statement. So fall over BFD. Yeah, and this is how you enable it, configure it for EIGRP. Let's, and this is a example of configuration uh, in a BGP network, and this is for OSPF. So let's take a look at the network or diagram that I created. And of course, I already configured BFD on these routers. So yeah, like I said, 2 steps. First is, let me go back to that section. I'll just check something here. So operation, benefits, configuration section, and the monitoring, okay, troubleshooting, okay. So yeah, so 2 steps. Um, First is enabled it on the interface itself, which I already did. So let me show the, here. The interface is gig0/0. Yeah, I already configured it on this interface. So let me just show you how you would do it. BFD interval, and of course this is in milliseconds, so 50, and this is the interval that you receive from your neighbor. So I'm also gonna put 50, and this is the multiplier, so it's gonna be 150, 3 times 50. Also, I'm gonna put 3, which I already did here. And then it did the same on the other, on router 2. So I'm on router 1. So I also configured this on router 2. Oops. Yeah, here, same command. And next step, or second step, is configure it on the under the protocol itself. So BGP in this case. So let me go back. So you actually followed this uh, configuration, or perform this configuration on router 1 and router 2. So same configuration. So let me do this command just to show you the configuration itself. So here, this is the BGP configuration, and this is how I configured BFD. So let me show you how you configure it. So neighbor, so under, so session fall on open, on peer route lost. So fall over BFD and enter. That's it. So I did the same on router 2. And this is how you verify it. Okay, and this is the command. So neighbor, this is our router 2. Um, State is up, and this is the interface where it is configured on. So let me do BFD neighbors detail. So if you want to see the more details about the BFD, you can issue this command. So session state is up and using echo function with 15 milliseconds interval and registered protocols, BGP in this case. And you can see other details as well. Okay, so yeah, that's how you verify it. So you can see it's the same command here. Yeah, let me actually try to shut down gigabit 0/0 port. Shut. So immediately we see that um, the neighbor is down, and we see that BFD session destroyed. BFD syslog. If we do show BFD neighbor, nothing. So neighbor is destroyed or broken. Neighborship is broken. So let me no shut that interface. BFD neighbors. Okay, so yeah, BFD session created and BFD session is going up. Now we see it up. Let me go to R2 as well. BFD, show BFD neighbors up as well. So, yep, that's it in this video. Thanks for watching.